Keep in mind that the addition of vector quantities is distinctly different and more complicated from addition of scalar quantities. So first we have the parallelogram law of vector addition. First, join the tails of the vectors at a point to make them concurrent. That means they meet at a point. Their tails are at the same point. From the head of B, which is here, draw a line parallel to A, which is this line here. Draw another line from the head of A here that is parallel to B. So we have two lines now. Those two lines we just drew intersect at point P to form adjacent sides of a parallelogram, where these opposite sides are parallel to one another. This diagonal of the parallelogram that extends to point P from this point here, the tails of the vectors, forms R, the resultant vector. So uppercase R is often used for resultant vector, or the total net vector, the summation of all the individual vectors, where vector R equals vector A plus vector B. We can also mention the triangle rule or the head-to-tail method of vector addition. So once again, we have vectors A and B in this two-dimensional space. Connect the head of A to the tail of B. So head-to-tail method. Here we have vector A. We're connecting the head of A here to the tail of B there. The resultant vector R extends from the tail of A to the head of B. Okay, tail of A to the head of B. That vector R in blue is the resultant vector. Now keep in mind, the addition can be done in the reverse order and we still get the same resultant vector. So we see that vector A plus vector B equals vector B plus vector A, and that equals the resultant R. So we're heavily focused in this class on forces and force vectors. Many problems in statics involve finding a resultant force. So to do so, we can use the techniques presented previously, including the parallelogram law and triangle rule of vector addition. However, another technique to find a resultant force will be introduced in the next section. This technique is called the component method of vector addition, and it's generally much simpler than the previously mentioned techniques. So illustrated below is the parallelogram law of vector addition of forces. So we have this structural component here, vectors F1 and F2. These two forces are acting at this point here. So using the parallelogram law of vector addition, we construct our parallelogram. Connecting this point to this point creates our resultant force vector, F sub r we can call it. So this is our resultant force vector, where F sub r equals vector F1 plus vector F2. Inside this parallelogram are two triangles. In fact, they are identical triangles. They're basically just rotated one from the other. So when using the parallelogram law or triangle rule of vector addition, we see that parallelograms and triangles are formed. Two trigonometric laws that are particularly useful in these problems are the law of sines and law of cosines that relate the lengths of the sides of the triangles and the interior angles. Keep in mind that these two laws apply to all triangles, including those that are not right triangles. Okay, so as we see again, we have this parallelogram. Inside of it, we have two identical triangles. So we're doing a lot of analysis of triangles in these sections of statics. So the law of cosines states the following, that uppercase C equals the square root of uppercase A squared plus uppercase B squared minus 2 uppercase A uppercase B cosine lowercase c. So if we know the lengths of two sides of the triangle and we're trying to find the third, and we know the angle opposite of that unknown side, we can apply the law of cosines to determine that unknown length. The law of sines states the following, uppercase A over sine lowercase a equals uppercase B over sine lowercase b equals uppercase c over sine lowercase c. So if we know, let's say, the length of one side and the angle that's opposite to it, we can find, let's say, the lengths of the other two sides if we know the other two angles. So these two laws of trigonometry become especially useful in many of the problems that we do in the first part of chapter 2, because again, we're using the parallelogram law of vector addition, and inside that parallelogram are triangles that are formed.